Welcome to the Frozen Case project. We are KBJ TEC.
Smartphones currently have a very powerful hardware that comes in a compact size. High efficiency has been achieved with these devices, but the problem of overheating still remains, which is worsened by the use of the case to protect them. For this reason, a new case will be designed, one that allows ventilation of the device through a dynamic change of its physical characteristics. This will take advantage of the thermal expansion that occurs in the materials from which it's built. Some of the key points that will be taken into account are polymeric material that expands at a relatively low and limited variation of temperature, taking the environments as reference. Mechanical design of the mesh that allows ventilation and reduction of case cost.
The goals of our project are design of an attractive case that allows better ventilation of smartphones, determine which polymer has the necessary expansion coefficient when subjected to temperature differences that allows the desired changes, while at the same time supporting a high number of cycles. Analyze the efficiency of the case using the ANSYS simulator on its mechanical and thermal modules.
For the resolution of our problem, the first step was the modeling of a design using a CAD software to use as base for the ANSYS workbench simulation.
An essential part of the design is the mesh, which consists of consecutive arches to create a geometrical shape capable of deforming in a predictable manner. These arches form a supporting structure for dozens of covering lids positioned precisely to allow their deformation in conjunction with the main mesh, making them open pathways for air.
The other parts of the case are the expanders, pieces that allow the whole function of the case. Their design is optimized to provoke the mesh to deform freely and move where necessary, while at the same time being the source of the deforming force. You may ask yourself, but how does it work? When the smartphone heats up, the expanding material causes a transformation of the physical appearance of the case's mesh. This opens previously closed channels for the air to flow and radiation to escape, thus cooling more efficiently. The final design of the case was modified when it was time to generate the simulation, mostly due to the processor time and simulation complexity increasing radically due to the very thin and numerous covers that would finally move when the temperature was high enough.
Simultaneously, it was necessary to determine the temperature differences the case is going to be subjected to during normal use,
Followed by the selection of materials for each part of the case and upload their thermal properties into the program. For the expander parts of the case, the material that will be used is low-density polyethylene, and for the mesh part, the polyvinyl chloride.
After that, the simulation begins, which consists of increasing the temperature the case is exposed to. As a result, when the material expands, the cooling of the device is achieved. The security of the smartphone isn't affected by this expansion. The cooling process is gradual, according to the heating of the phone. Once the device's temperature is optimal again, the frozen case returns to its predetermined form.
With this investigation, we conclude that the case increases the dissipation of heat. It allows better convection of the air. In common cases, radiation is trapped in between the smartphones and itself, but with frozen case, when it opens, it's released. As a recommendation, this investigation can be modified to be used in more kind of applications, such as in tablets and computers.